This is our second video on solving pairs of simultaneous equations where one of the equations contains a squared term. Make sure you're comfortable with what we looked at in the previous video in this topic before continuing with this video. Now, here we've got y equals x squared minus x minus 19, and the second equation is 2x minus y equals negative 9. So up here, we have this expression for y, and we've got a y in the second equation, which means we can substitute this expression in place of y in the second equation. Now, we need to take real care when we do this, so watch carefully. I've got 2x to start with, and then I'm subtracting the y, and y equals all of this here. So I'm going to have that in brackets. That's x squared minus x minus 19. Now, all of this equals negative 9. Now, we need to take real care with the left-hand side here, but what we've got is 2x minus x squared minus negative x, effectively, so that's plus x, and then minus negative 19, so that's plus 19, and that equals negative 9. What I'm going to do next is collect these like terms, 2x plus x. So that gives me negative x squared plus 3x plus 19 equals negative 9. And then I'm going to add 9 to both sides. That gives me negative x squared plus 3x plus 28 equals 0. Now, if it's possible to avoid, I like to avoid having a negative coefficient of x squared. So what I'm going to do is multiply the left-hand side and the right-hand side of this equation by negative 1. If I multiply the left-hand side by negative 1, I'm going to have positive x squared minus 3x minus 28. And that's going to equal negative 1 lots of 0 on the right-hand side, which is still 0. Now, this equation here is something I can factorize. I get x minus 7, x plus 4, and that equals 0. That has two solutions, x equals 7 and x equals negative 4. Now, we haven't finished. Each of these solutions has a corresponding y value that we need, and that will give us our two solution sets. To find the corresponding y values to each of these x values, we need to substitute these x values into one of these equations here. It doesn't matter which one, but I'm going to go with the first one. So if x equals 7, then y is going to equal 7 squared minus 7 minus 19. And that is 49 minus 7, which is 42, minus 19, which gives us 23. So the corresponding y value for x equals 7 is y equals 23. This is our first solution set. Now, let's see what happens when x equals negative 4. Y is going to be negative 4 squared minus negative 4 minus 19. Now, let's just treat that carefully. Negative 4 squared is positive 16. Subtracting negative 4 is the same as adding 4. And then we've got to subtract 19. So we have 16 plus 4, which is 20, minus 19, that gives us 1. So our second solution set is x equals negative 4, y equals 1. Those are the two solution sets to this pair of simultaneous equations. As I've said in all of the previous videos on simultaneous equations, we can check these by substituting them into the original equations and making sure that both equations are satisfied. Let's just check out this solution set in this equation, for example. 2x would be 2 times 7, which is 14. If we then subtract y, so subtract 23, we get 14 minus 23, which is negative 9, which is what we want. Similarly, if you wanted to be thorough about your checking, you could substitute the x and y values from the other solution set into these equations to make sure that both equations are satisfied. Here's the second pair of simultaneous equations that we need to solve. We have y equals x squared plus x minus 15 and 3x plus 2y equals 12. Here we've got an expression for y. So what we can do is replace the y in the second equation with that expression for y. We're going to substitute this y with x squared plus x minus 15 because we know that equals y. Now if we do that, this is what we get. We have 3x plus 2 lots of y, so that's 2 lots of x squared plus x minus 15, and that equals 12. Just note the brackets here. We've got 2y, which means it's 2 lots of all of this in brackets. Now let's expand and simplify the left-hand side. We have 3x plus 2 lots of x squared, which is 2x squared, plus 2 lots of positive x, which is plus 2x there, plus 2 lots of negative 15, which is effectively minus 30. And all of that equals 12. Now, on the left-hand side, I can collect these like terms. I've got a 3x plus a 2x. So I'm going to have 2x squared plus 5x minus 30 equals 12. What I can also do is subtract 12 from both sides. So that's going to give me 2x squared plus 5x minus 42 equals 0. Here I've got a quadratic equation. Let's see if we can solve this by factorising. Yes, we can. We get 2x minus 7 multiplied by x plus 6. That equals 0. So this gives us two solutions. We have x equals 7 over 2. And we also have x equals negative 6. We still need the corresponding y values to go with these x values. It doesn't matter which equation we substitute them into, although one might be easier than the other. In this case, I'm going to choose the first equation because if I substitute an x value into it, I get my y value straight away. I don't have to do any further rearranging, which I would have to do if I substituted into the second equation. So let's substitute x equals 7 over 2 into this equation. We get y equals 7 over 2 squared, which is going to be 49 over 4. Then we need to add on x, so that's 7 over 2. Now I'm going to write that as 14 over 4, just so I've got a common denominator. And then we need to subtract 15. And again, I'm going to write the 15 as 60 over 4, just so I've got a common denominator, just to make my life a little bit easier. So what we have here is 49 over 4 plus 14 over 4. That gives us 63 over 4 so far. And then when we subtract 60 over 4, we're just left with 3/4. So our first solution set is x equals 7 over 2, y equals 3/4. Now, because this involves some tricky fractions, it might be a good idea to check that this is correct. And we can do that by substituting these values into the second equation and making sure that the equation is satisfied. So let's do that. If x is 7 over 2, then 3x is going to be 3 lots of 7 over 2, which is 21 over 2. Then we're going to add 2y. So 2 lots of 3/4 is 6/4, which simplifies to 3 over 2. And when we add those together, we get 21 over 2 plus 3 over 2, which is 24 over 2. And 24 over 2 is the same as 24 divided by 2, which equals 12. So we do get 12 on the right hand side. So this is a correct solution set. Right, let's move on. Let's find the other solution set. When x equals negative 6, y equals negative 6 squared plus negative 6 minus 15. This gives us positive 36 plus negative 6, which gets us to 30, minus 15 gets us to 15. So our second solution set is x equals -6, y equals 15. Again, we can check this in the second equation. So let's substitute these values in here and make sure we get 12. So x is -6, which means 3x is -18. Then we're going to add 2 lots of y. That's 2 lots of 15, which is 30. -18 plus 30 equals 12, which is exactly what we want. So we know that we've got this second solution set correct.